Hi, welcome to part 2 of lesson 1.2, where we are defining basic geometric terms. The next term that we're going to be talking about is a plane, and a plane is a flat surface that extends in all directions to infinity. So I oftentimes will think of like a piece of paper as a plane. However, we have to use your imagination and visualize that all of the sides are extending into all of infinity. Okay, so it's a flat surface. So some ideas that we have behind planes is that through any three non-collinear points, there's exactly one plane. So if I draw 3 points, let me get a pen here. If I draw 3 points, I could lay exactly one piece of paper that would go through all 3 points, lay down exactly one piece of paper. I couldn't come from another angle and hit all 3, but there's exactly one piece of paper or one plane that would go through all 3 points that are not in a line. Remember, collinear means in a line, so non-collinear means that points that are not in a line. And a plane has 2 dimensions. I kind of think about it as length and width, but again, they go into infinity. When we talk about the symbol of a plane, we use a quadrilateral, and more specifically, we use a little parallelogram. A plane is either named with capital letters, and I should clarify, capital letters that are on points, or a single capital letter which is not on a point. So if you look at G right here, that's a capital letter. It's not by a point. So we could use just that single letter and say that this is plane G, or plane G, like that. Or you could use 3 capital letters by points. So points A, B, and C. And you could say plane A, B, C. In the room that you're at, I want you to look around and try to identify a plane. What would be an example of a plane? I'm in a classroom as I record this, and so I can look at the ceiling and say that's a plane. I can look at the floor and say, oh, that's a plane. I can look at the walls. That would be a plane. And now I want you to think about how when they intersect, what is formed. And we'll come back to that in just a minute. Another point term we want to talk about is coplanar. And what that means is that points are on the same plane. And again, you get a little hint with that one because you have almost all the letters of plane there, but coplanar means points on the same plane. Now, another term that is very important in this course is postulate or axiom. A postulate is an accepted statement of fact. There are no counterexamples. Everybody agrees it has to be true. So it's just a fact. So some of the postulates that we're going to be talking about in this first chapter are listed here. Now, I'm never going to ask you to give me the name. The book may ask you to give the name or the number, I should say, of a postulate, but don't worry about that. I want you to know what they say, though. The first one says, through any 2 points, there exists exactly one line. And we talked about this in our previous lesson. So if you have 2 points, you can draw exactly one line that will go through both points. There's only one line that will hit both points. Okay, so that's a postulate. That's your first postulate. The next one is a postulate that says if 2 distinct lines intersect, so let's call this line M, and here is line N. If they intersect, they will intersect in exactly 1 point right here, okay? There's no way you can draw those 2 lines so that they'll intersect in 2 points if they're distinct. The next one goes back to planes. It says if 2 distinct planes intersect, then they intersect in exactly 1 line. So I drew a picture of a plane. Planes are a little hard to draw. So if you have this one, we'll call this plane G, and we'll call this plane L. So plane G and plane L they intersect in all of these points along here, which actually will form a line. And it will go forever, because remember, planes go forever in all the directions. So this line will go forever in both directions, so that is a line. So if you look at your floor and the wall, and you look at where they intersect along the floor, that would be a line. All right, another postulate. Through any three non-collinear points, there exists exactly one plane. So if you have 3 points, I look at this tripod. Here's a point, here's a point, here's a point. Those 3 points will rest on the floor, and it will make this stand up. Let's do a few questions here. It says, use the figure at the right. What plane contains points N, P, and Q? So point N is here, point P is here, point Q is here. So what would be like the piece of paper you could put through all 3 of them? Well, it would be like the bottom of this box. So this plane. And you remember the way that we name a plane when we're given points is with 3 letters. So you could use the points N, P, and Q to name it, or you could say this plane is NRK, plane NRK, or line, let me see here. Where is the K at? Oh, the K is up here. Don't use K. Sorry about that. The K is up here. You could use NRQ, or you could use QPN, any of the 3 points on this plane to name that. The next one says, let me erase this so we're not confused on the next one. What plane contains points J, M, Q? So J, M, and Q. So look at that. Do you see a side of the box that goes through all 3 of those points? Well, here we have to use our imagination a little bit. It would be like if you took a piece of paper and sliced it diagonally through the box. That would be the plane that would contain those 3 points. And so we have to name that plane with 3 letters. So we can use JMQ, or we could use JMP, or PQM, any 3 letters on this plane. Let's look at the next question. It says, describe the intersection of plane JMR. So JMR, all right, that's this side right here, and plane NRP. So NRP is this right here. Here's the R back here. So it's basically, we're talking about the side and the bottom of the box. Where do they intersect? They intersect right here, which is a line. So the intersection, we want to use a little line symbol, would be line NR. The next one says, describe the intersection of plane MLQ. Let me erase MLQ. Okay, so the plane that would take all 3, it would contain all 3 points would be like the back side here of the box. And plane NRP. NRP. Let me use different colors. Oh, that's the bottom. So what is the intersection going to be? First of all, think about what is the shape of the intersection. It's a line. They would meet right here. So we would say that is a line, and it would be line RQ. Let's look at our next question. Are the following points coplanar or non-coplanar? So remember, coplanar means on the same plane. So let's look at this. Points R, K, K is up here, L, and P. All right, so we have 4 points. Is there a piece of paper that we could put that somehow set on that picture, picture it 3-dimensional, so that it would touch all of the sides? Well, this side right here, this is a plane, so these three are all on the same plane. These three are coplanar, but then it doesn't include that one. And let's see, if you have this point and this point and this point, you could go diagonally through and touch all three of those. So we would say that these are non-coplanar. They're not all on the same plane. Let's look at the next figure, or the next example. Points J, M, N, and R. Oh, yeah. That side contains all 4 points. So we would say that those are coplanar. All right, a few more questions here. It says, name the intersection of each pair of planes. So, number 15, planes QRS, QRS, and RSW. So QRS is the bottom of the box. That's how I think of it. And RSW is the side. So those are going to intersect right here at line RS. So we would say line RS. That's how you do that. And let's look at a problem out of the next set here too. It says name 2 planes that intersect in the given line. So first we have to find the line QU. So QU. So the 2 planes that would intersect here would be, let's see, this front plane of the box. So we would call that plane, we'll pick 3 letters, UQR. So that's the front. And then this side right here, so we would call that plane UXT. Or you could have said UQT. All right. And if we are looking at this problem right here, looking to see which this picture goes with here, XT. There's not a T on there, so these must be going with this right here. I'm going to just use this picture and just kind of give you another problem that I think you might run into. Let me see. How about this one? You might have a question that would say, is point U on plane ZSC. So plane ZSC is the yellow one. Point U is not on it. You would say it is not coplanar with these 3 points. All right, that is all we have for this lesson. And so go ahead and work on your homework and let me know if you have questions. Thanks for watching.